Today we'll be taking a looking at expanding binomials. And so first off, we'll start off by reviewing how to collect like terms, and then we'll go through expanding binomials and apply those expanding problems into a real-world problem. So as we're going through, we're going to take a look at collecting like terms. Now the important thing about like terms is that they always have the same variable with the same exponent. So if we look at this first example here on the left-hand side, we see that 3x and positive 5x, they both have the same variable of x with the same exponent of 1. And also the coefficients negative 7 and positive 9, they don't have any variables, so we can collect those together. So we can add the 3x plus 5x, okay, and that's going to equal 8x. And negative 7 plus 9 is going to equal positive 2. Now in terms of collecting like terms, I can't collect any more because 8x and positive 2 are not like terms, and so therefore we're done with that particular question. If we move over here to the right, we see again a few more terms that are here, and again terms are always separated by a plus or a minus sign, and so we have a term here that's 6x squared. There are no other terms that are an x squared. We've got a standard negative 1x. We also have a positive 1x, and those two things are together. And then finally we have a positive 13 and a negative 5 in the middle. And so this is also a set of like terms. So if we collect all of our like terms, we can add and subtract them. That's what we're doing. So you end up with 6x squared. Negative 1x plus 1x equals 0x. So I will just add that in as 0x. And then plus 13 minus 5 is going to equal plus 8. So to simplify this even further, we get 6x squared plus 8. Okay. Next thing that we want to do is look at expanding the following components out. So again, we're going to use the distributive property, and so when we're doing that, we're going to take the coefficient that's at the beginning, and we're going to multiply that coefficient by each term that's inside of the brackets. So 2 times x is going to give us 2x, and then we multiply 2 times positive 7, and that's going to give us positive 14. So we end up with 2x plus 14. If we look here in the middle, we have our coefficient at the beginning, the term at the beginning of the bracket is 3x. So we're actually going to multiply 3x times everything that's inside the brackets. So 3x times x, and also 3x times negative 5. So 3x times x is going to give us 3x squared, because x times x results in x squared. And then we're also going to do 3x times negative 5. So 3x times negative 5 is going to equal negative 15x. And then finally, we've got our other term over here on the right-hand side, and that's negative x times 5 minus x in the brackets. So again, we take that term in the beginning, and we multiply it by everything that's inside the bracket. So this is the same as saying negative 1x times 5 minus x. And so negative 1 times 5, that's going to result in negative 5. Because it's a negative 1x, it's negative 5x. And then negative 1x times negative x, the two negatives end up making a positive. So negative 1 times negative 1 gives us positive 1. And then x times x gives us x squared. So we end up with negative 5 plus x squared. Now this you can also write as x squared minus 5x, and both of those are correct. Okay, so that's just a quick review of expanding and collecting of like terms.